all rely on electricity from the utility grid to provide fundamental resources to our lives, including light, heat, and manufacturing of our basic necessities. Historically, electrical power systems were relatively simple. Utility power generation sources were connected to the electrical grid and closely controlled and matched with the loads of their customers. If we added more loads, the utilities would just add more generation capacity. The control of the grid and traditional electrical sources like coal-fired plants, gas generators, and nuclear power plants was the responsibility of utility companies. All was in balance. This provided stability and economies of scale with centralized cost and control. Today, our reliance on electricity is literally as important as food and water for our well-being. That electricity feeds our factories, data centers, buildings and homes, and even our electric vehicles. And the associated load growth has exceeded early expectations, putting stress on the existing infrastructure and grid. In addition, because of strict permitting requirements, it's increasingly difficult to build traditional fossil fuel or nuclear generation plants. In lieu of traditional plants, more renewable sources are being added like never before. So now, there's a significant change in the balance and stability between utility sources and our electrical loads. Coupling all of this and the electrical sensitivity of these loads creates a new need to provide clean, reliable power. This need for resilience to keep the power on, economic concerns to provide power at a cost-effective rate, and our desire to provide all of this in a more sustainable way is the energy transition. The electrification of everything is a focal point of the energy transition. New loads like electric vehicles and large data centers are added to the existing grid every day. In addition, there's been an increased use of renewables, energy storage, and other distributed resources, or DERs, on the utility and customer side of the meter. This also includes bidirectional flow of power, which makes us think differently about using and optimizing electricity at home, at work, and on the go. Here at Eaton, we're reinventing the way power is generated, distributed, stored, and consumed with our everything as a grid approach. This means we're using grid concepts of power balance between sources and loads and applying them to smaller parts of the power system. We're creating flexible energy systems to power our lives today and tomorrow, accelerating decarbonization, boosting resilience, reducing energy costs, and creating new revenue streams. With the proliferation of electric vehicles, including passenger vehicles, as well as fleets of delivery trucks, the amount of power used to charge them and the available storage they provide changes the game. The management of energy storage in these vehicles individually and as a group is the perfect example of forward-thinking opportunities with our everything as a grid approach. What does this mean for us? Here are some simple examples to think about. Traditionally, utility companies would plan around large electrical loads, like a steel mill, using 100 megawatts of power to make steel, and they would build infrastructure to supply those loads. Today, some of our larger data center customers use 100 to 150 megawatts, more than the power required to make steel. For data centers, this amount of power capacity and the move to lithium-ion batteries enables us to do more. With grid interactive UPSs, instead of only supplying backup power for utility outages, we can now store energy and apply peak shaving to reduce the cost of power from the utility. For factories, digitalization, including new low-cost embedded control and monitoring, yields a high ROI, helping us to manage power in a more efficient and reliable way. With buildings, microgrids and electric vehicle charging infrastructure for EVs and fleets of vehicles, and our expanded use of renewables and energy storage enables us to do more. It allows us to control both the sources and loads on our system. And finally, in our homes, we have an opportunity to take control of our reliability and efficiency with solar and energy storage, including using our EV as a battery backup system. All of these opportunities contribute to our everything as a grid approach in data centers, factories, buildings, homes, and even our vehicles. More and more, end users are taking power into their own hands by installing renewable sources, energy storage, and other distributed energy resources. When this is done in a more traditional way, these sources have limited defined benefits. For example, You may apply backup power or grid-connected solar. These had limited control and limited benefits without optimization. With a microgrid controller overseeing these sources and loads, that microgrid opens up a new realm of possibilities. Microgrids provide opportunities to supply reliable, efficient, and sustainable power. This control can be used to optimize large systems all the way down to the power in your home. The energy transition is as much about electrification and loads as it is about bringing in renewables and distributed energy resources. In some cases, we can create a virtual power plant by controlling or reducing the loads, relieving capacity on the grid or in our facilities. A more consistent, controlled, and predictable load is what utilities are looking for and is supported by our Everything as a Grid approach. Here at our experience centers, we can show you firsthand how smart breakers, renewables, vehicle-to-grid systems, and microgrids are changing the game with load control. With all of these new loads, we have to consider digitalization of our power systems. Just like rotary telephones have evolved into the handheld computer we use today as a phone, power systems are changing in a similar way. Cost-effective metering and control embedded in our sources and loads is now possible. This enables better management of our power systems. But make no mistake, this is an evolution. The energy transition still relies on the stable and relatively inexpensive utility grid to make it all work. As we move through this energy transition from traditional utility sources and traditional loads to more distributed resources with bidirectional flow and optimization, we'll experience a more resilient, efficient, and sustainable power system. In this video series, you can see Eaton's Everything as a Grid approach for various types of power systems, balancing sources and loads in our new and ever-changing world. In the meantime, if you want to learn more about the energy transition and our Everything as a Grid approach, contact us or your local Eaton representative to schedule a visit to one of our Power Systems Experience Centers today.